Alright, so now we got to finish this discussion on the cancellation laws and how they're different for inequalities as compared to equations. Here's one of the main differences. So if you had to solve this inequality, if that was given, you could proceed similar fashion as equations, but here's the crucial difference. When I multiply, or when we multiply both sides by negative 1 by cancellation law of multiplication for inequalities, it turns out to be an okay step so long as you switch this inequality the opposite way. Now that is very different than equations, different than anything we've done before. And of course there's a big question, why? Why should we do that, and can we prove it? That's coming up next. At first let us just try to practice learning to use the statement as it follows. The statement is you can go ahead and multiply by negatives so long as you change the sign. Multiplying by positives is okay, nothing's different. So in this case that would lead us to x is greater than negative 10, and that would be our final answer. Well, one version of it, or you could just write it this way. You can write it with interval notation, negative 10 all the way to infinity, interval notation. That would also be acceptable. Okay, that's what's different here. Let's try it again, this time with a different one. Suppose that was given excuse me. You can go on and multiply both sides by a negative number. Let's say we multiply both sides by a negative 1/2. Both sides by a negative 1/2. The cancellation law of multiplication for inequalities says it's okay to multiply by negative 1/2 so long as you change this inequality to going the other way around. That would lead us to x is greater than negative 5. And that would be an acceptable answer. Again, we've got to explain how come this is happening here. When we multiply or divide by negatives, we've got to change the sign. So that's what we have to explain. And that we explain in a couple theorems. And the theorems go something like this. So first one is called cancellation law of addition for inequalities. That's what the I stands for, inequalities, cancellation law of addition. This one says the same thing as the one for equations. You can add any number to both sides, no problem. It doesn't specify that c has to be positive or negative. Any real number would work. You can add it to both sides, keep the inequality the same, no problem. This is the same as regular cancellation law of addition. What's interesting is this one right here, cancellation law of multiplication. It's got two different scenarios. If it's positive, if c is greater than 0, that means if it's positive, then okay, you can slap a c on both sides, no problem. But if it's negative, if c is less than 0, then you can still slap a c on both sides, but you see this part right here is different. That part right there changed compared with this one. Whatever it was before, it has to change to the opposite when your c is negative. That's what's different. Now right about now you might want to hit pause. This is the pause moment. It's time to see what you're made of with your 3.5-pound brain and your fearless attitude. Can you prove it? Can you prove that it's okay to multiply both sides? Can you prove that it's okay to add both sides? And can you prove that in the cases when you're multiplying both sides by negative, you've got to switch the inequality? That's the question. So right now would be a good time to pause. Okay, if you haven't paused yet, here I'll give you one more chance to pause. I'm going to set it up for us. We're going to prove a little piece of that. We're going to prove that if a is less than b and c is negative, in other words c is less than 0, if this is given that a is less than b and given that c is less than 0, can you prove logical steps, perfection, beauty, and creativity reasoning like you've never seen before? Can you prove that AC is less than CB? Okay, but going the other way, it's greater than. Can you prove that AC has to be greater than CB? In other words, when you slap that C on both sides, actually I'd rather do it this way. AC, BC, keep the C on the same side. Can you prove that you can slap a C on both sides, but you've got to change the inequality? That's what you want. And again, another excellent opportunity for you to pause the video and see if you can get there. I challenge you. I defy you. Alright. This is the pause moment. Okay, come back in a couple hours and see if you got it done. If not, here's what we could do. A minus B. We're going to use this super strong definition of A less than B. Remember that one we talked about earlier? From this one, I'll just make the entire proof in green. This one says that B minus A is positive. That's the definition of less than, right? This one right here says that 0 minus C is positive. Again, by the definition of less than. Now if I have a positive times a positive, I should get a positive. Now we haven't talked about this one before, but this is called the closure of positive real numbers under multiplication. So if I take a positive times a positive, I will get a positive. That's what I just did right here. Deserves another axiom, but we'll come back to that in a second. So positive times positive gives you positive. This means that B minus A times negative C is positive. That's because 0 minus C is just still negative C. All I did is get rid of that 0. Now I could distribute that. That would give me B times negative C plus negative A times negative C is positive. That's because I just used the distributive law and definition of A minus B. Now we're here, we got to get there. We're here, we got to get here. What would be a good way to narrow this distance? Well, let's see. The definition of AC is greater than BC would be to say that AC minus BC is positive. So if I could get from here to here would just be the definition of greater than, and I'd be done. Right? If I can show that AC minus BC is positive, that means that AC had to be bigger. Well, here's where I am, and here's where I've got to go. So this one said, well, how much is negative A times negative C? That would be AC, and how much is this one? This is negative BC plus AC is positive. Here I use negative times negative theorem. Negative times negative becomes positive. And here I'm going to switch around and have AC minus BC is positive just by inspection, because all I did is move the AC over here and the BC that way. And now look what we did. AC minus BC is positive. That means AC had to be bigger. Yippee-ki-yay. That right there is a tight proof like you've never seen it before, explaining exactly why when we multiply by negative you have to switch the inequality. It's based on the very powerful definition of less than, and it's based on the axiom that when you take a positive times a positive you get a positive. The fancy name for that axiom is called the closure of positive real numbers under multiplication. Alright, that's just a little taste of awesome thinking. Alright, we'll see you guys here next time. Peace.